Hi, this is David Hartkop. About the time we were wrapping up the project is when I started having trouble with NASA. And then they suck all the air out of that chamber that you're in. And then the jet noses down, boom, you are weightless. Gravity is switched off like a light. Gravity, a force so constant in our daily lives we scarcely perceive its presence. For many of us, we are destined to live out our entire lives within its persistent grasp. So today's episode is by and large about gravity, or really just my personal experience with gravity. I think everybody's got gravitational experience they could share. Certainly things like walking. I guess first of all, it is interesting to note that gravity down here on Earth really is everywhere, and for the longest time people didn't even notice it was there. Well, how could you? It's kind of like being a fish being surrounded by water. Well, what isn't water? A guy named Cavendish in the 1790s had a series of experiments. He set up shop with an instrument that was a lot like, if you picture a mobile you'd hang in your kid's room. It was a mobile that had a couple of lead spheres, like miniature planets, hanging from it, and he built a neat little shack next to a cinder cone, and was able to tell how much those little spheres were attracted to the cinder cone. One way or another, he managed to work out the actual weight of the Earth in the 1790s. So, good job, dude. That's pretty amazing. I've been keenly aware of the phenomenon of zero gravity since I was a kid. I mean, maybe a lot of you have had the experience of watching astronauts on the space shuttle playing with M&Ms and globs of water and just thinking, why can't I go in space, play with weightless objects? And I even remember setting up a set in my parents' basement with a camera. I'd put the camera sideways. I'd hang a bunch of stuff from fishing lines when I was like 6 or 7. And I'd spend a lot of time in front of camera pretending to be floating around weightless, drawing on stuff. You get it lit just right, and you can't see the strings at all. So pretty fun. I mean, a lot of movies do it, but it's a very expensive special effect even still. Also, there really is a lot of interesting science related to things that happen in weightlessness. I mean, some of the cool experiments with biology relate to, how do spiders build their webs? Well, it turns out spiders build their webs just fine. But other things like cats, oh man, forget about it. Cats hate zero gravity. They are so mad when you put them up there because they like to be in charge. Well, all of us do, but they really like to be in charge of where their paws go, and frustrates them to no end. So bad idea to bring cats into space, I think. Something else really interesting that I've seen in experiments were those experiments with fire and flames, where you get to see how flames don't really burn up or down. I think it's kind of cool. They'll burn in a little sphere and kind of put themselves out because the heat doesn't rise away from them, doesn't really carry out the combustion product. So pretty interesting. I saw something else that was interesting. I don't think ever before there had been classified basic physics before some of these experiments that the Russians were doing, spinning little bolts in zero gravity. They discovered, for some reason, if you spin a T-shaped bolt, it'll spin just fine for a while, then it'll shake, and all of a sudden, whoop, it flips around and is now spinning but facing the other way. And right before your eyes, after a few more spins, whoop, it flips around again. And the Russians classified it until they could get a handle on what was going on. Pretty spooky stuff. And this was in the 50s or 60s. So a lot of keenly fun, strange stuff you can do in weightlessness. So I kind of had my own sketchbook. I tend to keep a sketchbook of ideas as I go along. And I had some ideas going for things that I would like to try if I had the chance to be in zero gravity. So there's some things related to, bubbles. If you put bubbles of air in water, well, guess what? They don't float up. They just kind of sit there inside the water like a gel. And that's pretty neat. But then you probably at some point want to remove those bubbles from the air. So design kind of a spinning bubble separator. Thought, wow, this would be a fun thing to try. I was pretty interested in the idea of what happens to air when you heat it up in zero gravity. Like, can you have hot pockets? Can you have hot pockets of air that kind of stay floating in one spot and not in another? And what does that look like? Do you see a heat wave that doesn't move? If you think of a candle lit and you can see the heat waves rising off the top of that. If you had a hot wire in zero gravity, what does that look like? I mean, can you have lenses that are made of air in zero gravity, which is pretty cool because now you could turn up and turn down the heat, and maybe you could adjust how much that lens focuses the light. I don't know, just kind of a fun idea. So I had some of these ideas written down. I went to film school, by the way, so still very interested in light and cameras, miscellaneous. But I had friends that I'd gone to high school with years earlier that were now going to the aerospace school at the University of Michigan. And I got a call from my friend Lindsay and said that her major professor had been encouraging her to join something called the Student Flight Opportunities Program. And this is a NASA-sponsored program that reached out to aerospace engineering students and kind of encouraged them to build an experiment and submit it. And if they were selected, then you'd get to fly aboard the training jet that NASA uses for training astronauts in zero gravity. So, by the way, it's called the Vomit Comet, and it's a big white jet, and it takes nosedives at the speed of gravity, basically. And, actually, it flies in a path that takes it up and down in kind of a parabolic curve. And for about 30 seconds at a time, you're in there and completely weightless. And if you do it enough times, it will make you throw up. There's some pretty good stories about the making of Apollo 13. You remember that movie with Tom Hanks? And a lot of the zero gravity scenes were actually shot aboard the Vomit Comet. So you might see that again. The zero gravity is realistic looking because it's real. Anyway, we started talking about different projects we could do, and she needed some ideas for projects. And I said, yes, I have some ideas, but I want to be on this flight. She said, well, you're not really an engineering student, but we'll talk. So I presented a couple of ideas. The bubble separator was kind of one thing. They liked the idea of the hot wire project, hot wire in zero gravity. So we spent some time. We wrote up the proposal for it, and lo and behold, we got accepted. Kind of went from there. We ended up needing to develop the project more, write up a whole test equipment data package, giant report that you have to submit to NASA, which was pretty fun. I got to do the diagrams and kind of come up with the basic premises for a lot of stuff, and then got to work with real live engineering students who could flesh it out in a little bit more detail. And had a pretty good time coordinating between University of Michigan and where I was in Los Angeles, and then another group of students that were at Iowa State. All of us came together and formed a team. Finally, after months of coordinating things by phone and internet, we all met up at the University of Michigan and worked on building our rack of equipment. In about 2 weeks of playing around in the aerospace lab, we managed to build this big sled of gear. It had a video monitor, it had a camera. In gravity, you turn it on and you could see how the heat waves would rise. It would make a shadow of heat waves. And that was kind of our baseline. About the time we were wrapping up the project is when I started having trouble with NASA. My team was totally cleared to fly, but I was not. They were kind of scratching their heads. They're saying, so you're kind of the outlier, right? You're not really on this team. I was like, no, I am. I came up with a project idea, did all the diagramming and working on the basic science for it. They're like, well, so what kind of engineer are you? I'm like, oh no, I'm a film student. I'm a film school graduate. I work at a movie theater, and I do freelance special effects. Like, oh, okay. So you're not really on this team, are you? And I'm like, no, I am. I promise you. Went back and forth a little bit, and it became clear that I was in trouble. I had to figure out, how in the world am I going to get on this flight? I have to fly. How am I going to do this? Well, it turned out that all I needed to do was essentially get a press pass, and that's what I did. It worked out that I got to be the team journalist, and borrowed some camera gear and went along and documented things, and they kind of turned a blind eye to me when I started taking apart parts of the experiment and helping them work on the wiring and get things set up for the beginning. But it was kind of my pass to the whole project was officially the person documenting our flight. So it was great. Houston, I'd never been to a restaurant/bar that was basically a Cajun astronaut space bar. There were a couple of places like this. You could go in and just get a giant basket of crayfish and eat them, and look at astronauts and pictures of spaceships on the walls. It was very unusual. It was less unusual, though, than the training that they had us go through. There were, I think, about 15 other teams that we were in this training program with, and part of it was classes we'd take in auditorium style settings, and part of it was this physical training program where they're teaching you what to do if the jet is depressurized. They're teaching you what to pay attention to in yourself, and if you're getting sick. And at one point, they put us all in oxygen masks. They put us into a hypobaric chamber. Hyperbaric is more pressure. Hypobaric is less pressure. They call it the altitude chamber. They put you in there, give you oxygen, and then they suck all the air out of that chamber that you're in. I mean, basically, they suck out the air to the point that it's like you're at the top of Mount Everest, breathing from an oxygen mask. And the whole point is to make you aware of your personal symptoms of what happens if you're losing oxygen. Are you going to recognize that you're going into hypoxia? You need to recognize for yourself if you're going to pass out and die, so you can get an oxygen mask. So they put you in a room, they suck out all the air, and they tell you, all right, now take off your mask and just breathe the non-air. And so you do that. And meanwhile, there are people video recording you through little tiny windows all the way around. So I've got a video of myself taking off my mask, and then you just kind of get woozy. You get really happy. At least that was my symptom. Geez, hypoxia is great. You get pretty goofy, and then they say put your mask back on, and then you're kind of fumbling to try to find your mask. Geez, though, some people get tunnel vision, and some people just get lightheaded and pass out right away. But yeah, pretty unusual. They pressurized us back up, and then it was time for the next crew. But it seemed pretty extreme. We were all a little bit nervous by the time we're finally climbing into this jet. Anyway, the jet itself was pretty cool. You think of a jet with a lot of seats. This one was just basically, I think it's a 737 with no, well, it's a KC-135 is what it is. And it's like an airliner with no seats, well, a few seats in the very back for those who are sick. And then all the rest is padded walls. It's all like white padding over every surface inside. And we spent about a week in this aircraft hangar, bolting our projects into special rails that were just set in the floor and getting everything set up. And we're in there alongside all these other teams. One of the interesting things is you are working at NASA, and they're very, very detail-oriented. And if you borrow one of their tools from their toolbox, by the way, there is a NASA toolbox. You borrow a screwdriver from this toolbox. There's a little slot with a label that says screwdriver size such and such. And if that screwdriver is missing, end of the day, this jet is not taking off. Like it's that it is a switch. This jet is powered by all the tools being put back in their slots. So oh man, the day of the flight arrived and we were so excited. At least I was so excited. They were excited too. My team was excited, but I felt like I was sneaking aboard. I got my press pass, and I'm like, I can't believe this, because we got to build this experiment, and it was basically secretly in my mind, I was thinking, this is the little experiment that I thought of all by myself before I even knew about the KC-135 program. And we built it, and I got here, and we're at NASA. So, oh my God, it was great. They make you lay down on the floor as the jet is going up, and boy, it climbs at like a 45-degree angle, and you are squashed against the floor at 2.25 normal gravity, basically. And you're just waiting, ultimate anticipation. Everybody's got their own special jumpsuits. We're all like dressed in our little NASA green suits. And then the jet noses down, and it's not like an effect that eases on. No, as soon as the pilot reaches a critical angle, boom, you are weightless. It's like gravity is switched off like a light, and all of a sudden you're just not in contact with the floor. The pressure goes away. It was not at all like being on a roller coaster or something where it's accompanied by a scary sensation or you're seeing anything scary. No, it was actually the absence of sensation. Gravity goes away, so too does your idea of up and down. And it's kind of weird to say this, but what happened was now, no matter what way you move yourself, it was kind of like you were grabbing a hold of the world and rotating the world around you. That makes any sense. Yeah, it's the ultimate narcissistic experience. Weightlessness puts you at the center of your own little universe, which according to general relativity, you actually are, but it was cool to experience it firsthand. So for the flight, they planned to take us through 20 dives like this. And boy, they gave us some motion sickness medicine, and it worked, sort of. But I swear, 20 dives through weightlessness / twice normal gravity will make anybody sick. So you kind of hang in there. They tell you the first couple of dives, they just said, go ahead and play. If you brought something interesting like a slinky or something you want to throw around in weightlessness, do that. Just kind of sit it out. Don't try to get your experiment going until you have your bearings, until you have your weightless wits about you. So finally, we did get to switch on our experiment, and it was great. It was very rewarding to finally see some results, and it was so cool because it looked like a little lens, made of hot air, and as soon as gravity hit again, it went back to the normal rising heat waves, looked like you'd see above a candle or a barbecue. But in those fleeting moments of weightlessness, the heated filament of nichrome wire actually piles up hot air around it. The air accumulates and becomes less and less dense in a very predictable way, and light moves through it like a lens. So, wow, holy cow, it looks like what we predicted, only a little bit different. So that's science for you. Kind of predict something, do an experiment, realize you're sort of right and you're sort of wrong. If you can walk away from an experiment with more questions than you had going in, then you're probably doing real science. Anyway, that experience of being weightless and just the perspective change for one, which was unexpected, of how your sense of up and down kind of seamlessly goes away, and you're just left with this very logical view of only what's in front of you. And when you grab the walls to move your body around, it's sort of like you're maneuvering the world around you. It was very interesting. Cooler than that was the idea that you could take an idea or a simple question and develop it with a team of people into a good experiment and get an experiment done and then get some results. And it was great to know. For 3 years after that, there were 3 other teams of students from the University of Michigan that did follow-up experiments with lasers and with better equipment. It was just very rewarding. So I did actually fulfill my job as team journalist as well. I spent the whole time basically with a camera in my hand, documenting everything from the building of it to our training and on the flight. So I had a lot of footage. I finally got back to Los Angeles and the dust settled. And I was thinking, how how could I turn this into a video that will get some interest and maybe something I could sell at some point. Something will be watchable in a documentary and something that's compelling. And how could I use it as an excuse to meet like a movie star? That's what I need. I need a movie star. Well, I guess they can't be in it, but I need a movie star to do like the voiceover for this. Who can I get? Who would be most appropriate for this? So. Forgive me, this is my first podcast. I'm trying to do a segue. Anyway, I'll leave you with this, and we'll meet again soon.
Gravity, a force so constant in our daily lives we scarcely perceive its presence. For many of us, we are destined to live our entire lives within its persistent grasp. Though weighty life is the norm, it is by no means the law.